Welcome to this video 1.5, index laws. So this is the last thing for you to learn necessarily for the assessment this unit, so you're probably very excited about that. And our learning goal for this one is that students will recognize the index laws and apply them to whole numbers. Okay, so you will at the end of this you'll be correctly able to apply the index laws to simplify some expression. Okay, right, you might be asking, which is fair enough, why bother using indices? Well, for instance, let's think to ourselves about the mass of the Earth. Whoop. Mass of the Earth. Is it really big? Is it really big? You might think, oh gee, is it 1,000,000 kilograms? Maybe 1,000,000,000 kilograms. In fact, I'll tell you what, it's almost 1,000,000,000,000,000,000 kilograms. And that's just a ridiculously large number to write. And so we use indices to make it a lot easier for ourselves by writing instead that it is 6 times 10 to the power of 24 kilograms. Now this is something special called scientific notation. Okay, where in science there's sometimes some huge numbers and some teeny weeny numbers that we want to be able to express easily, and so we express them as these times 10 to the power of kind of things, right? So this number, if we were to write it normal, it would be 6 24 zeros kilograms, and no one wants to have to write that all the time. So using indices is a very compact and easy and simple way for us to write stuff. Okay, right, let's have a look at some of these key ideas for us, because I actually talked before about the index laws. Okay, so this one's going to be law number 1 for us. Okay, so multiplying common bases. Alright, so let's have a look at this. If I had, for example, so common bases, if I had 2 to the power of 4 times 2 to the power of 3. Okay, I'm going to first expand that. Okay, so 2 to the power of 4 is 2 times 2 times 2 times 2. Okay, now that's that one expanded. Now I'm going to bring this multiply down here. Okay, that's the multiply from up there. Now 2 to the power of 3 is 2 times 2 times 2. So I've got 2 to the power of 4 here and 2 to the power of 3 here. Okay, but as you can see here, I've just got a whole series of 2's being multiplied. So now I can simplify that by rewriting it as an index. So I've got a repeated multiple of 2, and it's multiplied 1, 2, 3, 4, 5, 6, 7 times. Okay, so 2 to the power of 7 is equivalent to 2 to the power of 4 times 2 to the power of 3. Those of you who are very astute among us may have noticed that 4 plus 3 is 7. Okay, so what happens is that when we're multiplying common bases, we add the powers. So law 1, multiplying common bases, we add the powers. Add the powers. Okay, so let's sort of write a generalized statement for that. If we had x to the power of a, oops, not plus, times x to the power of b, that would be equivalent to x to the power of a plus b. So if the same base is multiplied, we add the powers together. Okay, let's have a look at when we divide common bases. Okay, right, so if we have, so this is going to be our law 2. Alright, so if we had maybe 4 to the power of 3 divided by 4 to the power of, I might change this 3 up a little bit, maybe 4 to the power of 6 divided by 4 to the power of maybe 3 again. Okay, so 4 to the power of 6 divided by 4 to the power of 3 let's rewrite that as a fraction, because remember divide by is just the same thing as a fraction. I'm going to expand 4 to the power of 6 at the top, and I'll write it in red. So 4 times 4 times 4 times 4 times 4 times 4. There's our 6 4's multiplied against each other. Now the other one I'll do in blue. 4 times 4 times 4. Now I can, if I've got a common one here and here, here and here, here and here, they all kind of cancel each other out because they're all 4 divided by 4 is 1, 4 divided by 4 is 1, 4 divided by 4 is 1. So that means all I'm left with is those 3 on top, which is 4 times 4 times 4. If I simplify that and write it as an index, I will have 4 to the power of 3 because it's 4 multiplied against itself 3 times. Now, again, those of you who are really on track here might have noticed that how can I use 6 and 3 and get 3? 6 minus 3 gets us 3. So, if we're dividing common bases, we simply subtract the powers. Okay, and we'll write ourselves a little generalized rule for that. If we have x to the power of a divided by x to the power of b, we're going to have x to the power of a minus b. Now you might think, well, what about negative powers? We might speak about that in class. It's a little bit of an extension stuff, sort of grade 9 level, but I'm sure many of you will be keen to get into that. Right, what about the power of a power? Alright, so let's have a look at that. That's going to be our law 3. Okay, and let's say, for instance, we had 3 to the power of 4 squared. Okay, so that squared's outside that 3 to the power of 4. Alright, so let's sort of write this out expanded wise. So I have 3 to the power of 4 times 3 to the power of 4. Because remember, that's what squared means. Okay, you just multiply it by itself. So 3 to the power of 4 times 3 to the power of 4 is 3 times 3 times 3 times 3 times, that's that times being brought down, 3 times 3 times 3 times 3. Right, let's count these up. I've got 1, 2, 3, 4, 5, 6, 7, 8 3's multiplied against each other, so that means I have 3 to the power of 8. Okay, so how can I use the 4 and the 2 here and end up with 8? Well, the answer is, when you have got the power of a power, you might notice that 4 times 2 is 8. When you have the power of a power, you multiply the powers. Multiply the powers. Okay, so that means generally if we have x to the power of a, all raised to the power of b, that will be equal to x to the power of a times b. Okay, easy. Easy as. Alright, lastly, you have no power here. Some of you might recognize that from Lord of the Rings. But what if we have 70, maybe, to the power of 0? Okay, so if a power, that's not a degree sign, that is a 0. Okay, what if we have 70? What if we have a number raised to the power of 0? There's an interesting one. It's just one that you just have to go with. Okay, what is the answer of a number times by itself 0 times? Just sounds bizarre to think about it, but you might think, oh, well, that's 0. But in fact, it's been defined. It has a definition. Defined as, okay, generally any number x to the power of raised to the power of 0 is 1. You might be like, what? But just go with it. Okay, it's been defined. X to the power of 0 is equal to 1. Okay, now you've got plenty of chance to practice some of these. There's some great extension activities and stuff you can get into that's sort of getting into grade 9 level content. And I hope you enjoyed this video and look forward to seeing you in class. Thanks.